Greetings, I'm Blackjack Fitz. In today's video, I'm going to be solving a puzzle by Marty Sears. This is Some Difference, and I'm very excited about it because it is a Somedoku, and you all know how much I enjoy a good Somedoku. And of course, I love a good Marty Sears puzzle, so this is a nice wombo combo. So let's go ahead and read the rules here. We've got Somedoku. It's 0 to 8 Somedoku, which I haven't seen anybody do yet. I'm curious as to the logic behind, or like why. We'll have to see what the rules have in store. Why we went with 0 to 8 instead of 1 to 9. But 0 to 8 Somedoku. So we're going to fill each cell with a digit from 0 to 8. And then for every row n and column n, there are exactly n unique digits. The remaining cells are filled with repeats. So there's just going to be one different kind of digit here, or all of these will be the same because that's row 1. But in column 5, we'll have 5 different digits and then 4 repeated digits. So for example, if this was 1, 2, 3, 4, 5 like this, then all of these cells would have to be from 1, 2, 3, 4, or 5. And because they have to repeat, because we can't have any more unique digits in that column. The same will be true for the rows as well. Although, yes, it wouldn't be 9. It would be 0. I forgot. We're in 0 to 8 land. Okay. Same difference. So each pair of adjacent digits on a turquoise line contain the same difference. This difference must be determined for each turquoise line. If there is a diamond present, its digit indicates the difference value of the line. Not all possible diamonds are necessarily given. Right. So I think this is where the 0 comes from, because you can't have a 9 there, but you could have a 0. Right, so the point is these could all be the same. And in fact, I hope we'll get one. That's kind of one of the fun things about Somedoku is those could, well, not this one, but these could all be the same digit. For example, this could all be, well, zeros, actually, because then it would be a 0 difference line. So that's one possible way to arrange that. The diamonds indicate what the difference is on those particular lines where there is a diamond. But obviously not all the lines have a diamond. So let's say the digit here was, the difference between all of these was 2. There doesn't necessarily have to be a 2 on this line. It could be 1, 3, 5, 7. And because there's no 2, that's still fine because it's the same distance or difference for each gap all along the line. Difference. No 2 pair of adjacent digits anywhere on a peach line may have the same difference. E.g., if there's a 2 next to a 4 on a peach line, there can't be a 5 next to a 7 anywhere on the line. So let's look at that. If this is a 2 and that's a 4, if this is a 5, we couldn't put 7 here because now the difference between 2 and 4 is 2 and the difference between 5 and 7 is 2. Right. So standard difference lines. Let's see. Note, a connected branching line is considered to all be the same line. So I imagine that's referring to these two things here. So the point is, this is all just considered one line. So it's not like this is one line and then this is a separate line. So these would all have to be the same difference. All of those have to have the same difference from that, which is actually quite interesting. We'll have to come back to that, I think, pretty early on. Okay, and then crop key. 2 digits joined by a black dot have a 1 to 2 ratio. One is double the other. So if this was a 2, this could be either a 1 or a 4 because 2 is double 1 and 4 is double 2. And that's all the rules. I will include a link to this puzzle in the video description. I hope you give it a shot. Marty's puzzles are always a good time. But now, with the help of chat, we're going to go ahead and try this one here. So if chat's ready, let's go ahead and jump into this thing. And I saw people were putting stuff in chat, right? As I was reading the rules, I didn't want to get interrupted, but let's see this one. Right. People just excited about a Marty Sears Somedoku, as excited as I am. Let's see. Okay. Cool. So let's think about, classic Marty right off the bat. We've got some M's at the top. This whole sort of streaming thing. That might be one place to start. My eyes are drawn to this one, though, because if I'm not mistaken, that's a length 10 line, because that's 8, 9, and 10. So each 2 digits along this line have to have a different difference. And so that's 9 different differences. And there are only 9, because you could have a 0 difference, a 1 difference, 2, 3, 4, 5, 6, 7, 8. Wait, did I count that right? 0, 1, 2, 3, 4, 5, 6, 7, 8. You can't have a 9 difference, because you would need to have like a 0 and a 9, which we don't have. Right. So there has to be, I mean, this is definitely the place to start, because we have to have a 0 difference along this line. And in Somedoku, the sort of perimeter are very powerful in Somedoku, because this whole sequence is always the same digit, because you can only have 1 digit. So whatever goes there has to populate all of these cells. And then also in row 1, it has to populate all of those cells. So like those are always going to be the same digit, right? But in these 2 exterior things, you can't have any repeated digits. Well, in this sort of strip, this is like a normal Sudoku row, and this is a normal Sudoku column, where you have to have all the unique digits, because you need 9 of them. So what that means is this whole sort of stretch here can't have a repeated digit, but we need to have repeated digits because we need to have a 0 gap for the difference. So so that difference isn't this, or this. So either these 2 are the same, or these 2 are the same. So whatever that digit is, it goes there or there. This seems entirely plausible, because you only get 2 different digits in the column. This would be more interesting, because that would be our only repeat in row 8. So maybe we can rule that out because of this. We need to have, I don't think so. Okay. So maybe this isn't the place to start. Well, no, because we do need the maximum difference somewhere. So we'll need like a 9 next to a 0 somewhere. So let me just kind of look at this real quick. So we could go like this. That's a 9 different, or yeah, that's a, wait, sorry, 8. Sorry, 8. I forget. Thanks, Marty. So 0, 8, we have an 8 difference. And then we could have like 7, and that gets us our 7 difference. And then we need a 6 difference, so 1, and then a 5 difference, 6. I think it's going to have to alternate kind of in this way here. 6 down to 2 is our 4 difference. 5. I'm not saying that this has to be this way. I think it has to be something like this, though. 2 to 5 is 3. 5 to 3 is our 2. 3 to 2 is our 1, and then 2. So something like, wait, hold on. Oh, that could be 4 even, though. Like, that could work, too. Yeah, it's interesting. Okay, so I think that this is going to be really forced, but I'm not sure that we actually start there. Because I think that it could be in a number of different ways. Could we start, can you do it like from 0 and then 8? You sure could, couldn't you? You sure could. You could definitely go 0 and then 8 and then do like 1 this way, rather than 8 and then 0 and then 7. Yeah. Okay, so I don't think we know exactly. I mean, I think we have a good idea. This will be forced once we get a digit, I think. So this is very constrained, but I don't see how we can use that line alone to actually start putting numbers in, unless I'm missing something. So let's think about this sort of section up here. Actually, what I'm going to do is I'm going to follow my own advice, which is to just, oh, I see. Okay. Oh no, that's a different difference line. Okay. Ah. Oh, wait a minute. Are all these the same? That might all just be the same. Let's use my own first trick, which is just color all of these. That seems like a good idea, because now this, well, yeah, this difference line has 0, which means this has to be green also, and this has to be green also. I think that's all just forced because these are the same digit, so it's 0, so that they all have to be the same digit. Right. That feels very straightforward. Probably should have started there. Okay. Now these are all the same digit, but it could be zeros. But this one can't. So this has to be a new digit. The reason that is because in this, well, because of this column, obviously. But that means we have our 2 digits. This digit and this digit are always, the 2 digits that exist in this in row. And it's the same thing in column 2. But what that means is, that doesn't mean that these are all pink. That wasn't a good deduction. They could be all pink. Oh, wait, it does. It does, because we only have 2 different, right, because we only have 2 different digits in row 2. So it can't be like purple or like light blue. That wouldn't make any sense. Light blue is a color I shouldn't use, but it couldn't be yellow. This couldn't exist because we only have 2 colors, and we've already identified them. They're pink and green. Now, if any of these were green, then the difference would have to be 0, and then this would need to be green also, which it can't be. So, in fact, we do get this sort of pattern here. But what's interesting is I don't think we know this one. That one can go either way, either pink or more green up here. Okay. Right. So this one can't be green because we have a difference of 0 here, so this can't be green. So this digit and this digit are the same, but the problem here is that these blue and pink could be the same. So I'm going to use these colors kind of loosely to start, because they could overlap. And I might have to switch to colors and letters here in a bit, but I'm not sure yet how that would go. So now I need to think about, I think this is really interesting, isn't it? How does that work? Because let's just think about what, I think maybe this has to be an extreme digit. Yeah, so, okay, let's imagine we put like a 4 here. Well, then we need 1, 2, 3, 4, 5, 6, 7, 8. We need 8 different digits to surround that 4. They have 8 different values from 4. So the point is, we could have a digit that's 4 away. It could be a 0. But then 8, you can't put an 8 because these has the same difference. And that's not going to work. So I think we could get away with, I think this is either 0, 1, 7, or 8. I think because we don't have all 9 different digits surrounding this, because we only have 8. So let's say this was a 1. We could have like 2, 3, 4, 5, 6, 7, 8, 1. And now we have a difference of 0, 1, 2, 3, 4, 5, 6, and 7. But we don't, so we don't need the 0. So this could be 2 or 0, like that. And all of this works fine. Conversely, and that's going to be identical logic for, if we just did 7 and then replace that with a 1, this all works just fine, except for, obviously, I have an existing 1, so 2, right? So that works fine. So I think that this cell is going to be 0, 1, 7, or 8. Now I wonder if, I was wondering if, because Well, yeah. These are the three different digits then in column 3. It's not true for row 3 though. Because this is in row 4. So these, well, I mean, it is 3 different digits here, just because of the sort of logic. All of these have to be a different difference from this central digit. So these are 3 different digits, but these are the 3 different digits in this sort of conflagration. Now, I can say that these two are the same because they have to have the same difference from green. So they're either... So could all of these just be green? I think it can. Sorry, I'm bouncing around so many different lines, but I'm not totally sure exactly where to look here. So could all of those be green? Then all of the differences are 0, and green is just a 0 cell. That seems perfectly reasonable, to be honest. Or these could be... Well, could it actually? Could these be different? Let's imagine those are blue. Now, what's this? That's green or blue. Well, it's not a 0 difference, so that would have to be green. And then green and blue would have to have the same difference from whatever this digit is. Hey, GDC, welcome in. I'm so glad you're here. It's always nice to have GDC in chat. Come solve this puzzle for me so I don't look stupid on YouTube. Right. No, I'm having a really good time with this. There's a lot of like things I can see, but I'm just not 100% sure how to use them just yet. Yeah, so this feels really interesting though, in that... Oh, another thing I just realized. Sorry, I'm bouncing around more. All these have to be the same, don't they? All of these are the same. All of these are the same. All of these. That's really weird. That's really weird. So those are all the same digit, aren't they? Oh, no, that's not true. That's not true, because there can be 2 different digits. Sorry. There can be 2 different colors that have the same difference from whatever the central cell is. This is 0 to 8 GDC. Yes, 0 to 8. And these little diamonds on the same difference lines tell you the value of the difference. So, for example, if all of these were the same, the difference is 0. So then green would have to be 0 because that's what this diamond is saying. So all of them would be 0. Okay, so I want to come back to thinking about this one then, because it sort of feels weird that this could be different. This now has to be green, doesn't it? Yeah, yes, very good point. Very good point, Sarah. These are definitely not all the same because, well, even if it was a different color, that's too many repeats in column 8. So yes. So this one isn't 0 or 8. We can say we could, if we wanted to, do something like this, because if it was 0 or 8, there would only be one. You have to be able to go on opposite sides of the of whatever the central digit is in order to have 2 different digits. But yeah, I'm not prepared to leave that pencil mark in quite yet. So this one then, we've got some difference x. Back to x, that's x. So now we need some... What do I think about 0 on a black dot? Oh, very good point. Ah, thank you. I don't like the idea of 0 on a black dot. Right. So, as I was saying, if this is the scenario, all of these have to be 0. Ratfinks, you are a hero. But look, there's a black dot. What's double 0? I mean, I guess if you put 0 on it again. Is that fine? Does that work? Shoot, did my voice just crack? Crap. Double crap. Shucks. Shoot. Is that fair? Tarnations. 0 is double 0. Yeah. 0 is definitely double 0. I also like that, Sarah, that you phrased that as, what do you think about this? Yeah, I don't think 0 and 0 are in a 1 to 2 ratio because 0, 0 is undefined. Okay. I'm not a mathematician. So, but there might be another way to prove it, but yeah, one is double the other. But is 0 double the value of the other? I don't honestly know. Since I have you in chat, is that meant to be a step here, or is there another way to prove? I'm assuming that this isn't true. 0 is definitely double 0. Okay. So what you're saying is I can't rule this out in the puzzle right now. Okay, thank you. Fair enough. So this may or may not be true. Anyway, let's go back to thinking about it the alternative way. It's really nice to have you in chat for that. I appreciate it. So let's just play with a number here. Let's say, 2 and 4, 2 and 4, right? So now that's going to be a green 2. Well, 2 and 4 was probably a bad option. Let's go 5. So that's a gap of 3. That's a gap of 3. So how would this work? I mean, how could that work? Because, well, maybe if I went 4 and 5, is there a way that this works? 4 and 6? No, because now our gap is 2. That has to go to 6 or 2. I don't think there is a way that this works, right? Oh, let's see if I can scroll the rules up a little bit here. So these are just same difference lines and different difference lines. Yeah, so I think the line in row 7, column 3 here must have a difference of 0. Yes, that's what I was trying. This is what I was trying to get at. I don't think that this is possible, because it just doesn't work. This would, well, first of all, this would have to be a 2 because the difference is 2. And yeah, I mean, this one works, but then now we've got a difference of 4. So how could we? This would have to be in the middle of these 2 digits, and there's just no way to make that work here. So I think that means that these are all green, and that means that they are all zeros, which I think is going to do some things. In particular, it's going to make this a 0 because 0 is double 0 for sure. Now, digits. Okay. Now this can still be 0. It sure can. Right. This can't, though. So we've got a true black dot relationship here. This can't be 0 because we've already used our 0 difference. So blue has to be a different value. So this is a 1, 2, 4, 8, 3, or 6. Standard black dot stuff here. But what's interesting is this is the 2 different digits. So these 3 digits go in this row. So What does that mean? Can this be the 0, or do we need the 0? It could be 8. I'm wondering how, thinking back on this line at the beginning, and now we've got the start to it. That actually looks very likely. I'm not sure it's required, though, because we have to have a 0 next to an 8 somewhere on this line. And that gives us our 0 and then our 8 gap. If this wasn't that, I guess this could be 8 then. And then this could be 8. Does that mean that just these are from 0s and 8s? Is there any other way to do this? Because if this is, let's say this is a 0. Well, if this is a 1, then we can't, so we need a 0, 8 somewhere. There has to be an 8 in here, which means that has to be 8. Right. That feels way more obvious. Because none of these can be 0, and we need a 0, 8 next to something. So one of these two is 8. Either 0, 8 here or 0, 8 here. So that means this is 8. Does that mean that this is 0, or could this be 8? I think that could still be 0 or 8, couldn't it? Because this gives us our 8 gap, and this gives us our 0 gap, and then this could just start the 7, that sequence type thing. But, okay, so this one I don't think we know. But I do think that means that we get the rest of this row, because we talked about this being really forced, right? So we need to have a 7 gap, which means 8 to 1, because we can't use 0 in it. So, and then we need to have a 6 gap, which goes like this, and then we need to, so we have to sort of alternate in this pattern from here. 5, 4. So now we have, let's just double check this line. We have a 1, a 2, a 3, a 4, a 5, a 6, a 7. We're going to have an 8 and a 0 there. And that's going to be all of them. Nice. Okay, so this is going to be either 8 or 0, which means that this is going to be either 4 or 0. This can't be 0, because then we would have 2 different zeros here. We said that these 3 had to be the different 3 digits. So that's a 1. Yeah, this is really nice. Okay. Very nice, Marty. I don't know that we're going to need to follow up on coloring for all of this. We'll see if we do. So this now is 0, 1, or 4. Okay, and then we have our 0, 8, 4 here. So these are all in that regard. That one can't be, that's brilliant. So we get the 8 there. So this can't be 8 now, because then we have a 0 for the reason we talked about before. These can't all be the same. And if those are the same, then all of these have to be the same. So that's not 8. If it was a 0 here, then this has to be 8. We have to sort of bounce back and forth, which doesn't work. So because it would be, first of all, just even putting that 0 and 8 here, now we're cracked. Or we've got, it just doesn't work, because it would have to be 0, 8, 0 is the only way that works. Now we've got way too many doubles in this column. So that has to be a 4. And now I think this has to be 0, and that's our 1 repeat. Right? 8 minus 4 is 4. 4 minus 0 is 4. And then this has to be, wait, how does that work? 4 again? That's too many things. I think I messed something up. Okay, hold on. My logic is flawed here. 0, 8, and 4 are only digits, right? That can't be 0 or 4, so it has to be 8. This has to be 0. It can't be 8, because all of these would be 8s, and that's too much. So this has to be 0 or 4. If this was... Oh, thank you, GDC. Very nice. Got it. So I'd assumed that it had to... Okay, so the logic about this not being 0 is correct, because if that's 0, we have to bounce all the way back up to 8. So this is a 4. I just missed the possibility that we could go to 8 here. So now we haven't used any repeats yet, making this a 4 again, using our only repeat now in the column. Very nice. Okay, cool. Took me entirely too long to see that. Okay, so now we know this is our 0 gap on this square here. So this can't be a 4. So that's 0 or 8. We don't know what pink is yet, I don't think. Do we know what this is? So what do all of these have to be? Oh, so okay, right. So whatever this digit is, actually, this has to be a 6. Is that right? I think this has to be a 6, so that these are 2 away from it on both sides. So in other words, this digit has to split the difference between these two in order for this to have the same difference going in either direction. Right. Sorry, I haven't done these lines in a while, so I feel like the logic feels very new and fresh again. So this can never be 0 because we'd have a difference of 6 when our difference is 4. So this one's 8. And now this isn't 4 or 8 or 0. But yeah. Okay, so this now isn't 0. So that's a 4 or an 8. So this is a 4-8 pair, so that's not 0. And then all of these are 4s and 8s, actually. Now what does that do? That gives us our last digit here, doesn't it? So we have 0, 8, 4, and 6. So these now have to be not 0 or 4. So I think this has to be an 8, 6 pair. And that can't be 6 because it wouldn't go there. So that's 8. That's 6. This is 4. That's 4 or 8. So this has to be 4 or... No, 2. Ah, that's really good. Very clever. We can't put 4 or 8 on this. Because we've already put 4 and 8 on here, and we can't repeat a digit in these cells because it would have the same difference with this sort of central line. So this has to be a 2. This has to be a 4. Now, this, it could be 8. I keep wanting to take 8 out of this because I've got an 8 there, but that's not, like 0, 1, and 8 are all on here. That would just force this to be a 7. Let's see now. If that is a 7, 6 and 8 break because they're the same difference away from it. So that now isn't 7 actually. 1, if this was 1, we have 0 and 2, which breaks. So this isn't 1 either. So this is 0 or 8. I wonder how we're going to sort that out. Probably from the column. What do I make of this digit? That's a great question. What is that digit? We've got a difference of 2 here. So this can't be another 8 because that would be the same. It can't be a 4 because that would be the same difference as these two. So it must be a 0 then. Very nice. Now, what does that do for us? This is what I love about Somedoku, by the way, is you have to like put something in to do this cell, right? Like you never just like do a few clues and then have Sudoku hard like all the way in. Every single cell has to be earned. Like it's not like a terribly complicated deduction, but you don't just get that by Sudoku. You gotta earn every square, which is quite cool. Yeah. All right, seeing some agreement in chat. Thanks, Marty. I love this. I really love that, right? Okay, so do we have our digits yet? 0 and 6 and 7. If this was an 8, that would be our 4 different digits, which would mean that this had to be 6, 7, or 8. Couldn't be 8. Oh, that is freaking amazing, actually. Um, yeah, that's very cool. Okay, so imagine this was 8. Now we know that. Oh wait, no, that's not quite true. Shoot. Okay. Yeah, because this could still be 6. Ah, okay. For some reason, I was thinking if this was 8, then it had to be pink, which doesn't make any sense at all. The only thing I'm noticing is that I mean, obviously that can't be 8. Okay, I'm hallucinating doing this puzzle. Um, so okay. If there is a uniqueness argument here, which I believe you, I'm not even gonna try to sort it out though, because I don't want to use it. But I definitely believe you. I have no doubt that that's true. Okay, so, whoa, screen just went black. Sorry about that. I think I have like a hot corner on my. I don't know what happened there. Hopefully, you guys are we back? Are you hearing me? Somebody say something nice in the chat. Okay. Oh, geez, I gotta like get rid of all my hot, all the hot zones with my mouse accidentally going somewhere inappropriate. So are we meant to think about like this one? This is, yeah, I mean, this is an interesting. How does this work? I think we have to have a repeated digit here, right? So whatever this is, these can be 2. No, that's not quite right. Because let's say this was like a 5. This was a 6 and a 4 and then a 3. Well, this would have to be a 1. I'm sorry. That's a bad example. Because, but maybe that is actually interesting to think about. Yeah, because if this was a normal same difference line, you could just do something like 4, 5, 3, 2, and all of that's fine. Then this could be another 4 or a 6, and that could be a 4, right, and a 1, and all of that's fine. Although I am seeing now, this is interesting too. That's all of my repeats in this row. Anyway, but this doesn't work. The point I'm trying to make is that this doesn't work for this line because this difference is 1, which would mean that needs to be 1. And I think that actually is very forcing here because if this difference, because it's very hard to go far down from here, right? Like you could go to 0 here and then 2, 3. So we don't actually need to repeat a digit. I think that's all fine. And then that could be a 1. This can't now repeat though, so that would have to be a 3. Sorry. So this seems like a plausible way to sort of sort this out. We don't have any repeats here. We don't have any repeats here. The digits in the thing. I'm not saying that's what it has to be, but I thought it was going to be more. You might want to edit that out of the YouTube video as it gave my name. Did it? Oh, geez. All right. I'll have to double check that. Thank you. So Dorlier is saying that one of the issues with Somedoku is that you need a lot of clues to disambiguate it. I think maybe that comes down to flavor, like what you like. I actually hate doing Sudoku to disambiguate a puzzle, so it's one of the things that I like about it the most. But the tricky part, what makes it difficult to set, is to create a grid that doesn't look overly cluttered in order to do that, which is very tough to do. So the way that I've done it is a lot of trying to make neat patterns or like straight lines with them, because I feel like visually it's easier, even though there's lines like in every cell. It sort of feels minimalistic in the sense that it's the sort of same grid pattern. That's been sort of my strategy for dealing with the fact that it's very easy to end up with a grid. Like I have a puzzle that's done that I actually kind of like that I haven't published and I probably won't publish. because it just looks chaotic. And I don't like that. Anyway, but yeah, I mean, it's not going to be for everyone. The other big issue with Sudoku, I think, is that there's a lot of tracking how many repeats. Like towards the end of a puzzle, a lot of times you're going like, okay, 1, 2, 3, 4, 5, 6. Okay, I can't, counting unique digits in these middle ones in this sort of zone, where it's kind of harder to sort of keep track, just do it by eyeball. Where it's very easy to be like, okay, just one repeat down here, So, okay, what can these be? I've given up on this line. Sorry. I don't know what that's doing. I think that this has to be a low digit. It's not 0 because all these would have to be the same. If it was 2, it could be like 0, 2. Oh, wait a minute. Okay. Okay, hold on. This is really interesting. I think this is an 8. I think that that's an 8. Okay, so let me try to explain it. There's stuff going on in the chat, but I want to try to explain this because I think this is very beautiful, actually. I'm going to claim that there's a repeat in those 5 cells. And that's because either these 2 digits are the same digit, the difference away from this central cell. So let's say this was a 3. That could be 6 and 6, and that's going to be our repeat. But if it's not, it's going to have to go up and down from whatever this is, and it's going to have to subtract this value from itself. So one of these digits will always be a 0. And that's true no matter what this is. If this is a 4, we go to 840. It's the only way it works. So either these 2 digits are the same or it involves a 0, and that is going to use up the only repeat in this row, which means that has to be an 8. That's very cool. That is very, very cool. That also means this isn't a 0. Yeah. So, okay, these are fake digits. But I mean, it's a beautiful deduction, but like, what does it do? What does it do for me? So, I mean, now I can rule 8 out of all these. So this isn't a 4, right? Okay, so this actually is very limited. So if we look at sort of the whole realm of possible digits for this cell, well, it can't be 8 because then both of these would have to be 0, and we've broken, right? So it's not 8. It can't be 7 for the same reason because then, again, both of these would have to be 7. Can't be 6 for the same reason. Both of these would have to be 0. Can't be 5 for the same reason because both of these would have to be 0. So 7, 6, and 5 already come out. But 4 comes out too. Because if this was 4, we can have a 0. But now what's this? Or we could have an 8. But now what's this? It can't be another 8 and it can't be a 0. So 4 doesn't work either. And 0, oops, sorry, I meant to take 4 out of there. So 0 doesn't work either because, like we already argued, all these would have to be 0, right? So that's not 0. We're down to 1, 2, or 3 in this cell. I'm looking to see if there's any logic on column 6 here. I don't think so. We've got 1 pair already. Right, so if this is 1, we're looking at... Now, okay, can these actually be the same? Okay, maybe. Let's see. If this was a 1 and this was 2 and 2. The thing is, because we have this, that all has to be the same, these now have to be different. So this could be like 1 and 3, and that's okay. And then 3 and 4. Yeah, I don't think we can rule that out. Maybe we can rule out the other way though. I can kind of see that in my head. If this is a 0, this has to be the same digit. And now this can't go down, so it has to go up to 3. And then this is now 3 to 4. No, it really doesn't. It really doesn't break. But I think this is what we're meant to think about now. Yeah, I think this is what we're meant to think about now. Right. So let's think about what these digits can be, because we have 0, 6, and 7 here. So that's 3 of our digits. So one of these digits has to go here, and that's not a 0. And that's not a 0. So it's not 0. So there's a 6 or a 7 here, for sure. So we have a 6 or a 7 in this string. So how do we get there, right? 3, 6, 9 doesn't work. 3, 0, 3 doesn't work. So I don't think this can be a 3, because 3 never gets to 7. 3, 6, 3, 3, 6, 3, 6. I actually do think that works, right? Like so. And now we've got 3, 6, 7, 0. This just becomes a 0. Okay, that does work. If it's a 2, we could go like 4, 6, 8. And now this becomes 0 or 8, actually. So 2 works. Can we get there from 1? We might not be able to get there from 1. 1, 2, 3, 4 is the highest we could get. We need a 6 or a 7 here. Right. So it's not 1. Oh. We're down to 2 or 3 here. Row 8, column 4 is 3 times row 8, column 6. Row 8, column 4 is 3 times row 8, column 6. Yes. Ooh, it could be the same digit. Right? It could be 3, 0, 3, I think. Does that work here? Then this would be 6, 9, 6, 3. I think that path works. Does that not work? Oh, yes. Right. You can't have 2 repeated digits in this cycle. Thank you. Very good. Okay. Because we know that the repeated digit is allocated to, I said before this, but it's actually this. It's either these two are the same or it repeats a 0. So we can't go to 0 and then bounce back up. That's not a 0, is a different way of saying this. If that is a 0, then these two are the same and we've got 2 zeros. Okay, cool. So I think that rules out 3, because I think 3 was the only, 3, no. It doesn't, does it? Because 3, 6, 9, 6. And now we have 0, 6, 9, 7 works. And then this could be 6 or 0. This would be, yeah, so that doesn't work. 9. Okay. Repeated 2 digits in row 8. What do I, dang it. I don't feel good about putting 9 in a 0 to 8 puzzle. I don't feel good about that. So that's a good question, chat. Hold on, let me give chat a little bit of love for that. Thank you. Thank you all very much for that. Much appreciated. Right, so have we officially ruled 3 out of here? Oh, I feel daft for that. Okay, because yes, we can't go 0, 3 or 3, 0, 3. We can't go 3, 6, 9. And we can't go 3. Oh, could we just Yeah, we can't go 3. We can't go back to 3. So yes, the point earlier that this has to be triple is correct, because this can't go down to 0. So this is always going to be double that. Or it's always, it's always going to be double that. And then this is always going to be triple that. It always is going to be. And that can't be 9 because 9 is not one of the digits in the puzzle. Very good. So I think we've gotten there at last. 4, 6, 4 or 8. I think we can do that. Unfortunately, I'm not sure we know. And then this now is 2 or 6. This is 0, not 4. Oh, no, it could be. That's the whole thing we were arguing. That's not 4, though. That's a 1. Because whatever, this is going to be a repeated digit, because that is either a 0 or 4. Now, if that's 0, that's 2. If that's 4, that's 2 or 6. Oh, that's interesting. So this is a 2-6 pair. Because we can't have any more repeats in this row. What are these digits? They're not 0, 1, 2. They could be 3. They're not 4. Could be 5 or 7, I believe. Right. So 3, 5, or 7. And we don't get any 3s in the corner. We do get 3 zeros in the corner. Does that count? That would be true for all Sudoku puzzles. Or not zeros necessarily, but whatever that digit is. There's always exactly 3 of whatever this digit is, because that one can't even be. So what am I missing? Probably a lot. This can't repeat a 5, because we've already got our repeat there, so that's not 5. So 3 or 7. Okay, so we have an actual difference here. It's not a 0 difference, which we probably could have assumed, but no, I don't know. This could have all been the same, except for these 2 digits aren't the same. So this digit is going to be the intermediary between these 2. Row 7, column 7 is the last even digit. 7, column 7 is the last even digit. That's true. Yes, because we have odd and we have even, so we have to be going alternating between odd and even on this line. There's a parity thing going on here. They're either all, I did learn this the last time I did same difference line. They're either all evens or it alternates even odd. And since we know that it's not all evens because of this, that has to be even. That's going to give us all of our evens here, and it can't repeat, so it's not 2 or 6. So that is a 4 or an 8. And now these can't be even, so these have to be odd, which means... Oh, I'm sorry. It could be odd too, right? Yeah, sorry. I think I was making a generalization about these. It could go 1, 3, 5, 7, 9. That's perfectly fine. So it's either the same parity or direct alternating parity, which feels like the most obvious thing when you think about it, but it sometimes helps to think about it. So these now have to be odd, and they could be any odd digit. 1, 3, 5, or 7. This one can't be 5. For the same reason that one couldn't be 5. Righty? So, if this is... Do we know enough about this yet? We might. Right. This is, like, this one's all odd. So, none of these can repeat. So, like, that can't be 1 because these would have to be the same digit, because this is an all odd line because we know these 3 are odd. So that's going to be also odd. And this one can't be 1 or 7 because if that was a 1, then both of these would have to be 3. And if that was a 7, then both of these would have to be 5. And that doesn't work. So that's not 1 or 7. That's 3 or 5. This, for the same reason, can't be a 7 because these two can't be 5. So that's not 7 either. That's a 3, 5. And now that's a 3, 5 pair in the column. So that's not 3 or 5. That's 1 or 7. Now pink is getting kind of restricted, actually. If we think just in these two columns, we sort of pencil mark the whole thing. They can't be 3 or 5, 0, 8 or 4. So 3, 5, 0, 8 or 4 from just column 9. And they can't, oh, I already ruled out 5. Okay. So 1, 2, 6, or 7. I thought I was going to be able to do better than that, actually. Okay. It's not 6, because then 4 and 6 would have the same difference as 8 and 6 over here. So they're not 6. I might as well do that one too. All right, well, let's see some things here. There's lots of stuff going on. Okay, let me start with startup. Column 4 has all its uniqueness. 6, 7, 0, and then 4 or 8. That's true, but I don't think that gives me this. But this needs... okay, that's actually... no, it doesn't, because this could just be all zeros. Okay, I mean, I can do this, though, right? That might help me here. So it's going to be 0, 6, 7, 4, or 8 are the only options here. Now, it can't be 6. It can't be 0. Sorry, so it can't be 6 or 0 because we already have those here. It can't be 4 or 8. So that's just a 7. That's lovely. So 0, 1, 2. This could be a 3. Can't be 4. It could be 5. It can't be 6, 7, or 8. So that's a 3 or a 5 there. Right. Okay. Now row 6, column 6 is odd. So we're here. That is true for the logic we were talking about before. This digit has to be between these two. So it can't be 1. Because then both of these would need to be the same digit because we can't have 1 on either side. So that's not 1. Okay. I think the difference should be 1 on the line that contains row 6, column 6. Okay. Dorlier is suggesting that this line, this is 9, 8, 7, 6. Yeah, I did think that. So this line, the difference saying this needs to be a difference of 1. What else would it be? It's not going to be 3, 8, right? Just from I think from these two. 3, 8, 3. 8, and then this has to be 8. Yeah, the point is, because these are different, we need to have a gap that's less than 5, for example, probably significantly less than that. So 7, 4, then this could, now we need to go back to 7, and then 4 only works. And this couldn't be like 7, 4, 1, because then both of these would have to be 4. Yeah, so it does have to be a gap of 1. So if this is 8, that's 7, that's 6, that's 8, that's 7. If this is 4, then that's 4. So these two are the same. Because they're just going to alternate. You can't get from one to the other. So those two are the same. Does that help us in this column yet? We've got these two being the same. Sort of. All of those digits are, you don't actually need the fact that these are the same. You have just 1, 2, 3, 4, 5 different cells that are only taking 3 different numbers. So everything else has to be unique. So there can't be any more 0, 4s or 8s or 6s or 3s or pinks. So this, for what it's worth, is not 0, 4, 8, 6, or 3. Okay, so we'll just leave that there. That is true. So let's look at this column because we've got 0, 2, 4, and 8, and then this digit, right? Let's double count that. 0, 2, 4, 8. That's 4 definitive digits. 0, 2, 4, 8. We only get one more. We haven't had a 3 or a 5 yet. So 0, 2, 4, 8, and then 3 or 5. So this cannot be 6. That must be 2. This cannot be 2 then. This must be 6. 6 can't be next to 0, so that must be 4. Okay. 2. If this was... No, that still works. It could be all 4s. It's either... So what's interesting is it's either 3 8s or 3 4s that are duplicating there. But now this digit has to be 0, 2, 4, 8. Oops. Let's do it in center marks. That's terrible. But actually, if it's not 0, it's pink. And pink can only be 1, 2, or 7. So it's either 0, 1, 2, or 7. So it's not 8. It's not 5. It's not 4. It's not 3. That's a 0 or a 2. Which means actually all of these are 0 or 2. Difference of 1 on the blue line. Thank you. Swing back to that real quick. 4, 4, and 3. Very nice. Now that makes this an 8. And I think that makes this not 3, right? Because we've got our 4s here. So that one's not 3. So that's interesting because that's either 1 or 7. So it could go 7, 5, 3, 1, or 1, 3, 5, 7. So these are different. And these are different. So this is a standard 1, 3, 5, 7 line. Existing somehow. We'll have to sort that out. I don't know that we have it sorted out quite yet. But what digits haven't appeared? We need a 6. Well, let's hold on. What do we got going on here? 0, 2, and 4 only. That's only 3 different digits. We need 5 different digits. So this can't be a 0 or we wouldn't have enough unique digits in row 5. So that is in fact an 8. And that means we need this to be not 0, 2, 4, or 8, but I don't think that's going to be breaking news here. Row 2, column 4 is not 2 because the column row 2, column 4 is not 2. 6, 8, 7, 0. So these are all zeros then, and they're greens, not pink. Oops. There we go. Fair enough. Very nice. Row 8, column 9 is 5 by row. Row 8, column 9 is 5 by the row. That is true. It's very true. Very, very true. So this isn't a 1 anymore. We need 2, 6, and 7. This, row 4, we have 0, 4, 8, and 6. So that has to be the 6. So now we have 2 or 7 here. 2, 7 pair going on. Righty. So probably we need to count our columns. We've got 0, 2, 8, and 4. So, we've done that one already. What about this one? 0, 2, 3, 4, and 6. That's 1, 2, 3, 4, 5. 6. We need another one, so that has to be the 8. That has to be the 4. Okay, so we've got just one line left to think about. We're getting, we're getting pretty close here. Both of these work in terms of this. Only 6 was broken there. Okay. Right. So, is it line logic or is it Somedoku logic here? We have 0, 2, 4, 8. That's only 4 digits. We need to have a new one, so that can't be 2. So that helps. All of these now become 2s. Now 7 something 7 doesn't work, so that can't be a 7 anymore because they would have the same difference from whatever this is. Column 4 already has a repeat. I think might have already gotten to the punch on that. Yeah, I think we're okay here. We just have to look at what can be here. So if this is, okay, this can be 2 because what do you put here? That doesn't work. So this is either a 6, which it can be, or a 4, which it can't be. So that is a 6, meaning this is a, oh wait, no, I was thinking it was the same difference line. Okay, sorry. All of that was complete nonsense. This line, or this cell, just surely by Somedoku, is going to be restricted. Can't be 0. It could be 1. Can't be 2, 3, 4, 5. Could be 6. Can't be 7 or 8. So that's a 1 or a 6. So if that goes 7, 6, all it's saying is that can't be 5. Do we have our repeats in this row, possibly? That's only 2 unique digits, 3, 4 unique digits. So we need 2 more digits here. Okay, so 1 or 6. If that's a 1, then I mean that could be a 1 even. Oh, all right. What's the last piece here? Row 6, column 7 can't be 2 by column 7. Right. Yes. That can't be 2. But I think it could still be 1 or 5. If that's a 5, then that is another repeat. So, okay, so looking at all of these digits, this is great Somedoku logic here, actually, I think. All of these digits can only be 1, 3, or 5. So we get 3 digits there. 4, 5 different digits. We need 6. So that has to be a 6. That's really cool. Now this can't be a 5 or it would be a same difference line. That's awesome. Okay, so 1, and now I think do we need the 5? 0, 1, 3, 6, 7. 1, 2, 3, 4, 5. We need a 6th. So that does have to be a 5. Whoo! Very nice. I like that a lot. Oh, I really like that. Okay, my favorite part. There, like some of the way that these stars worked, but absolutely my favorite part was this 8. Getting that 8 was so cool because you didn't know what this was at the time, but you knew that it was either repeating these 2 digits or repeating the 0, so this couldn't be a repeat. So it sorted that all out and gave you this whole line. That was awesome. Yeah. Oh, I like that a lot. Thank you to chat for help, and thank you for watching the video. Until next time.